Hello, and welcome to Ancelus Basic Training. In this session, we're going to continue with the description of the key list field type in the Ancelus database. Key lists are linked lists of keys associated with another key, where the list is unique. In the last session, we created a small database, inserted a part number, and inserted two serial numbers associated with that part number. And then we wrote a little utility that would list out the linked list of serial numbers for each part number in the database. So the question is there another way that we can use to load up the linked list structure in the Ancelus database, the key list? The answer is there is. We can use AT-load. Now, AT-load normally only loads a key and its items and its foreign keys. That's the intent of the AT-load facility. However, when we created our database, we wrote a simple little schema file that had a serial number, a part number, a foreign key for the in the serial number table, and a linked list in the part number table. I'm now going to make a small modification to that schema file. Watch very closely what happens to this serial number to part number, or serial numbers for part number in my next file. I now have a new piece of information in here. It's the same as it was before. It's a key list. The owner is part number. It points to serial number. But I'm going to say there's an automatic field associated with this list. And the automatic field associated with this list is the foreign key in the serial number table. What this entry does is it tells the system to automatically load the linked list every time a foreign key is added to the serial number table. Every time I add a part number to the serial number table, the underlying API will add a serial number to the part number linked list. So how do I do that? Well, the first thing I'm going to do is I'm going to go ahead and rebuild this database from scratch. So I'm going to, just for the fun, I'll time it again. It won't actually make any difference. But now I'm going to use this schema file which has this auto parameter for the linked list. 50 milliseconds. Looks exactly the same as before. Part number, serial number. The serial number has a foreign key. The part number has a linked list of serial numbers associated with it. But rather than inserting my serial numbers with the foreign key, I'm going to use a rather large comma-separated variable file that contains 1 million serial numbers. So here are serial numbers and part numbers. For every serial number, I've chosen a part number at random. And of course, there is a part number table. Here are all of the part numbers that I'm going to be loaded in. So what I'm going to do is I'm going to load 500 part numbers into my part number table. Then I'm going to load 1 million serial numbers into my serial number table. And in the serial number table will be a foreign key, which is a part number, and that will automatically load the linked list of serial numbers for the part number. So first let's load in my part numbers. Should I time it? It doesn't really matter. So I'm going to load 500 part numbers into my part number table. Took 5 milliseconds. I now have 500 part numbers. Now I would like to load 1 million serial numbers into the serial number table, and I want to load 1 million part number foreign keys into the serial number table, and I want to load 1 million serial numbers into various part number linked lists. What does that take? That takes this will take a little while to load 1 million serial numbers. That actually took 2.4 seconds. And it loaded up the linked list of serial numbers for each part number. How do I know that it loaded up the linked list of serial numbers for each part number? Well, it turns out I have a utility. Do you remember when we wrote the utility that lists all the part numbers in the database, and for each part number, all the serial numbers in the list of serial numbers for the part number? That list, that little program is still perfectly valid. And if I execute that, I think I ought to pipe that to more. I think I ought to spell it right. List 2. And so here is a part number, and here are all the serial numbers associated with that part number. This goes on and on and on. And if I think about this, I'll have to think a little bit. 500 part numbers and 1 million serial numbers randomly associated with those 500 part numbers. I think that's 2,000 serial numbers for every part number. So this list obviously goes on and on and on. By the way, what happens if I execute that program and send it to the null device? And time it. That took 0.4 seconds. I listed out 1 million serial numbers and 500 part numbers in 0.4 seconds. So why did it take much less time to get the data out than it took it to get in? Well, there's several reasons, but the most obvious reason is when I loaded up those tables, I had to load them up from disk files, and I was constrained by how fast I could read the disk. In this particular case, I'm sending all this information into the null device, so the disk is not involved at all. So it's obviously much faster. But still, 1 million serial numbers in 0.4 seconds. Now, there's one more question we might want to ask, and that is there another way to list out the serial numbers for the linked list of serial numbers for each part number? And it turns out there is. We're going to be seeing this utility in later sessions, but I'm going to give you a little sneak peek right now. We have a utility called TQL. It stands for Threaded Query Language. The Threaded Query Language utility allows you to create an XML file that says which fields do I want to query. And I'll give you a sneak peek at one of those XML files. Here is an XML file which my TQL utility can digest and produce results for. And basically what it says is, I start off with a TQL tag, and I say I'm going to use a vertical bar as a delimiter. Okay. Then I say I want to list out the contents of a key. And I'm going to say as PN. So I'm going to tag all of my PN records with my little lowercase pn. Within the key, then, I want to do a list of SNs for PN. That's my linked list structure. So I say list. I'm going to tag it with a little lowercase sn. Then I'm going to close my key tag, and I'm going to close my TQL tag. So what happens if I execute my TQL utility and pass it that file name? And what did I call it? I call it TQL. There it is. And I want to pipe that to more. We get really exactly the same pieces of information. Here's a part number. I put a little PN tag in front, and here's all the serial numbers for the part number. We get some additional information, and that is we say the records that we're going to send out with this TQL, there's going to be two different record types. There's going to be a part number record type, and there's going to be a serial number record type. And here are the columns for the part number record type, one column. And here are the columns for the serial number record type, one column. In general, there would be many more columns. But if I actually do that and send this to the null device and time it just for fun, and it's about 0.6 of a second for my million rows. So here is a little hint of how we might actually list the information in these linked list type fields. This is the end of this session. In the next session, we're going to be taking a look at another linked list field type, namely the foreign key list. In the foreign key list, the requirement that the list be unique is relaxed. Thank you very much for watching. We'll